In this video, we'll look at question 46 from the 2017 exam.
In this question, an arrow is being fired from a bow vertically upwards, something I don't recommend you try at home, and if you do, don't say that you saw it in a step maths video. The arrow weighs this much, and the green graph here shows us the force exerted by the bowstring on the arrow as a function of distance as it leaves the bow. We are supposed to find the kinetic energy as the arrow leaves the bow and the maximum height it reaches. So they even tell us that the work done by the bowstring is the area underneath this line. That's why I've shaded it in lighter green. And that area equals 192 Newton. That's the length of this side times 0.4, the length of the other side, divided by 2 because it's a triangle. And that's 38.4 joules. That's the work done by the bowstring, but it also must be the kinetic energy of the arrow because no energy is lost anywhere in this ideal case. So all the energy which the bow gives, the arrow will take. So that's the first part done. Let's now focus on the second part. So first of all, I'll denote the maximum height reached as h. All the kinetic energy the arrow has at the bottom will get turned into gravitational potential energy at the top. You can write this fact as an equation by conservation of energy. Gravitational potential energy is of course mgh, and we know the value for the kinetic energy, that's 38.4 joules. Now when we express the height in terms of the other variables, and when we plug in the numbers, we get 160 meters. So the kinetic energy at the bottom is 38.4 joules, and the maximum height reached is 160 meters, which in the exam was option B. In this question, however, it was quite easy to use common sense, and maybe if you were short on time, this question would be reasonably easy to make an educated guess about. Some of the options were that the maximum height would be 32 kilometers, 16 kilometers, which is obviously wrong, bearing in mind this is a bow and an arrow.